So hello everyone, my name is Dany, I'm a student at the University of Lausanne, and today I will present you my master thesis on social wound care in Camponotus. So let's start with a bit of context. So a few years ago, the first case of wound care behavior were described in the termite hunter species Megaponera analis. So in this species, the ants provide wound care by an intense licking at the wound. In addition, they use the content of their metapleural gland to inhibit the infection. And through this wound treatment, they manage to significantly decrease the mortality of injured individuals. But for now, there is no publication mentioning wound care behavior in other species than Megaponera analis. And despite the high diversity of the Camponotus genus, there is no wound care reported in any species. So my project was therefore the aim of my project was therefore to investigate the potential wound care behavior in this genus. So for this purpose, an ant was experimentally wounded. So one of his legs was cut at the femur, and then it was put back in the colony and observed. And we investigated several species. So actually, all of them show wound care behavior. So here you can see an individual of Camponotus maculatus licking at the wound, the injured leg of one of its nestmates. But wound grooming was not the only interesting behavior. We also observed a worker biting at the basis of the injured leg until cutting it off. So I'll show you a short video of this behavior. So here you can see with the yellow dot the injured ant, and here is a worker biting at the basis of its leg. And here you can see that the ant managed to cut off the injured leg, and then she will so lick the new wound. So this interesting behavior was observed in Camponotus fela, variants maculatus, and also in Camponotus floridanus. And we decided to continue the experiment with Camponotus floridanus because it's a well-known species and its genome is sequenced. And so, yep. So to correctly describe the behavior, we set up a second experiment in the same way as before. The amputation occurs between the coxa in the trochanter, so it's the same link between the coxa and the femur, and it happened on average 4 hours after the wounding. And here in blue, it's still the prevalence of wound grooming, and in red, it's the prevalence of amputation behavior, which is the time spent biting at the trochanter. So we can see that both behavior were provided in a similar way. And here in blue, it's still the prevalence of wound care behavior. And the red curve is also wound grooming, but this time it's after the amputation. So as we can see, after the amputation occurred, the wound grooming decreased highly. So in the second time, to assess the benefits of such behavior regarding the mortality due to the injury and its infection. So yeah, we did isolation experiment, and in this experiment we infected the wound with a solution of bacteria. So the results of this experiment were quite interesting. So here is a survival plot. On the x-axis there is the timeline in hours, and on the y-axis there is the survival probability. So in green here we can see IUSSI ants. So as we can see, they have a high survival, which was expected. In blue, there is ants that have been injured and put in contact with a sterile solution of PBS. And in red, it's the ants that have been injured and infected with the solution of bacteria. So as we can see, the infection has worked and caused a higher mortality. And so this is the same plot as before, but with several new treatments. So let's start with the yellow one. So in yellow, it's ants that have been injured and infected with the bacteria, and then they have been put 1 hour in the colony. before being put in isolation. And as we can see, there is they don't have better survival than the positive control in red. So it suggests that the wound care provided during this hour were not efficient to stop the infection. But on the other ant, we can see in purple here the survival of ants that have been injured and infected and put back in the colony until the amputation occurs and then put in isolation. So we see that they have a survival similar to IUSSI ants. So this clearly shows that the amputation behavior is efficient to inhibit the infection and is highly beneficial in terms of survival. And the light blue curves, it's ants that have been injured and infected. And then after 1 hour, I artificially amputated them under a microscope. And so we can see that they have a better survival than the positive control in red, but this difference is not significant. Still, we can see that it seems that an infected leg that has been amputated, they have a similar survival as a sterile injury. So if we compare this with Megaponera, so as I said in the introduction, Megaponera use the content of the metapleural gland to inhibit the infection. And this is not possible in Camponotus because the vast majority of the Camponotus species have lost their metapleural gland throughout evolution. So this could be this could therefore be the reason why they have evolved this this behavior. So it could be an alternative way of dealing with injury. And in Camponotus, it has been so that they emerge the wound care behavior emerge in a favorable context. So as a termite hunter, these ants are at high risk of injury, and this ecological context led to the emergence of wound care. But in Camponotus, it's not that easy to explain